Hello everyone. Hope you're having a great Thanksgiving holiday. I've taken some of the data from the Chapter 16 assignment and changed it a little bit so you can see the math but not have me do all the work for you in the video. For this example, I've changed the monthly demand in the months of February, March, April, and May. And I've also given you some different cost constraints over on the right-hand side, but those aren't going to come into play to determine our capacity. Those are going to come into play after we determine how many workers we have. But looking at the numbers and going along with the announcement I posted a few minutes ago, let's break this down into a couple of segments. First of all, we know we have a demand here of 48,000 for the month of February. And we've got some other data over here on the right-hand side that's going to help us. And I'm going to break this data down here a little bit to help you digest it a little bit better, and you can determine how involved you want to get with the formulas. But first and foremost, it says that we can make 4 units per hour per worker. And that number is important for us to calculate how many hours of work we need. We know we need 48,000 units in February, but how many hours will that take? And if we take that 48,000 and divide that by 4, that tells us that we're going to need 12,000 hours of production from our employees. Now we also know that our employees in February work 20 days, and we know that each employee works a total of 8 hours per day. So we have 20 days times 8 hours. We have 160 hours of work available per employee. And if you remember from the book and the problem, we are only building the demand we need, no extra, no less, in the months of February and March, and we're going to vary the number of workers we need to accomplish that. But very simply, if we have 12,000 hours of work and each employee can work 160 hours per month, all we have to do is divide the number of hours we need divided by the number of hours per worker, and that's how many workers we need. In essence, we need 75 workers to work 8 hours a day for 20 days to get to 12,000 hours, and they can make 4 per hour. That'll get to 48,000 units. So if I take the math the other way, 75 workers working 8 hours a day, working for 20 days, and making 4 units per hour, they can make 48,000 units. So it ties back to that number that we have for February. And you can do the same math in March. If you take the 76,000 units, 800 units that we need, and divide that by 4, we need 19,200 hours worth of work needed. And we have the same number of days, 20, and they work 8-hour days. We have the same 160 hours that we calculated up here. So if we have 19,200 total, and each employee can do 160, guess what? We need 120 workers to do that job. And there you see, in my table, 75 workers made 48,000. We need 48,000. Our ending inventory is 0. We built exactly what we needed. We moved to March. We're starting with no inventory. We need to build 76,800 units. It's going to take 120 workers, which we calculated down here, working 20 days to produce 76,800 pieces, and that leaves us with no ending inventory. So by varying our labor count, we had to lay off 25 people from January to February, and we had to hire 45 people from February to March. we can then run some separate numbers to multiply the number we hired by the cost of hiring, the number we fired by the cost of firing. We had no ending inventory, which means we had no holding costs, and we had no back order because we built exactly what we needed. So in the months of February and March, we had no back order costs and we had no holding costs. Now we did have some labor, 12,000 hours worth of labor and 19,200 hours worth of labor that we'll have to multiply by our labor rate, but we worked no overtime. We only worked the 20 days and 8 hours a day, so we had no overtime costs. So February and March are pretty straightforward. Now what happens when we move into April is the book says we're going to keep our employment level. So whatever we had in March, 120 workers, we're now going to have 120 workers in April and 120 workers in May. We can't change that number anymore. What we can change, though, is working overtime. And if you look at the demand we have for April, it's 100,000 units. And going about it the same way, we will need, if we divide that by 4, we'll need 25,000 hours of work to make the number of widgets we need. And we already know with 120 employees, we're going to get 19,200 hours of work out of those employees. We calculated that indirectly last month because that's how many it was going to take to build our 76,800 pieces. So we have 19,200 hours of regular time work available, and that means we're going to be short because that 19,200 can only build 76.8. We need 100,000, so we're going to be short about 5,800 hours. And to say that another way, we need 25,000 hours to build 100,000 units because we build 4 per hour. Working straight time, we only have 19,200, which is your 120 workers times 8 hours a day times 20 days, right? So we have 19,200 hours in the schedule with regular time. We need an extra 5,800 hours to build 100,000 units total. But we have this little quirk that the problem mentions in that we can only work 5,000 hours. So we have 19,200 available. We can only work 5,000 hours overtime, and that's per government regulation. So we can only work, regardless of our demand, 24,200 hours. But we need 25,000, so guess what? We're going to be short. But with 24,200 hours, we know we can make 4 per hour, so we can make 96,800 units. The demand was 100,000 units, so we're going to be short 3,200 units. And what happens in that case in manufacturing, you're just going to take that shortage and move it to the next month and add it to your demand. So instead of needing 40,000 next month, we're going to need 43,200. We're going to have 40,000 plus the 3,200 from the previous month. But for April, there's your calculation. We needed 5,800 hours of overtime, but we're limited to 5,000. So we only got 96,800 out the door, left us a shortage of 3,200 pieces. And you can do the same math for May, but note your demand is going to be 40,000 plus what you carried forward, so 43,200. You can't vary this. You still got 120 workers, and when you do the math, you're going to see that you can produce 76,800 pieces, just like you could back in March with no overtime. But you only needed 43.2. The difference between what you can build and 43.2 is your 33,600 of extra ending inventory that you have. All right, so a couple of things to note. Now that we know how many workers we need and how much overtime we need, now we can go back over and start plugging in costs. Hiring costs, $25. Here we had to hire to go from 75 to 120. Firing cost, we had to fire to go from 100 to 75. Holding cost, $15. The only place holding cost comes into play is the last month, because we carried an extra 33,600 units times whatever the holding cost is. The labor rate, we know how many hours we're going to work. That's what these four are. And then we have our overtime hours times the overtime rate. Only 1 month has overtime, and it was capped at 5,000 hours. And lastly, a back order cost. Anytime our ending inventory went negative, we have a back order cost. And that back order cost is going to be the total back order, which is 3,200 positive. That's how many we didn't get billed, but we have 3,200 to carry forward to build next month times the $25, and that would be your back order cost. If you sum up all of these costs times the units over here from the table, that will wind up being the total cost for you to run this production model. If you have any questions, drop me a line, and have a good day.